Mercatale, a small village in central Germany, has been a center of crucible manufacturing expertise since the 19th century. And for more than 135 years, that expertise has been the core asset of the Carl Nolte Company. Today, that company, as part of Morgan Molten Metal Systems, continues to manufacture Noltina clay graphite crucibles, Noltina silicon carbide crucibles, and a variety of ceramic foundry products. This video takes you inside our factory and shows you how Morgan MMS craftsmen use both time-tested traditional techniques and today's most modern production processes to produce the world's highest quality, best performing crucibles and foundry products. The crucible manufacturing process at Morgan MMS begins with premium quality graphite, clay, silicon carbide, and other materials. These materials, dispensed according to scientifically formulated and job site proven recipes, are essential to producing crucibles that will meet our customers' demanding requirements. Our automated material storage and dispensing system uses computer technology to ensure that each batch of material is precisely compounded for the crucibles or foundry products being produced from that specific batch. At Morgan MMS, we manufacture crucibles using a wide range of materials and offer an enormous selection of sizes and shapes to meet our customers' often highly individual requirements. We also use a variety of manufacturing processes to create crucibles with specific performance parameters. These processes include rib forming, roller forming, and isostatic pressing. To build the industry's leading high-capacity crucible, we start with a huge ball of clay graphite material. Large chunks of the pre-mixed material are assembled piece by piece and kneaded and pounded by skilled hands into the specific structure, density, and shape needed for the crucible forming process. For the Noltina 3 metric ton capacity crucible being made here, this hand shaping requires about 4 hours to complete. Next, the crucible mold is lowered over our carefully shaped clay graphite ball, now dusted with graphite to prevent the clay from sticking to the mold. 3 men work together to flip the mold so that the crucible material is now in the bottom as the mold is moved to the rib forming machine. The forming device, called a rib because of its shape, is then lowered into the mold. As the turntable holding the crucible begins to rotate, a hydraulic ram presses the rib into the clay graphite material in the bottom of the mold. It exerts pressure up to 5 metric tons. After the mold is removed and flipped, the crucible is carefully removed. This automated process produces a crucible with a far more uniform shape and density than is possible with hand-forming techniques. Rib-forming small crucibles uses a manual system taking advantage of mechanical leverage to apply the pressure needed to form the crucible in the rotating mold. Roller forming is the production process we use to manufacture Stabil brand silicon carbide crucibles used by customers worldwide. After the mold is filled and closed, a stainless steel roller, here bilge-shaped, is lowered into the spinning mold and pressure is applied, displacing the crucible material and compressing it onto the mold bottom and sides. Roller forming molds and rollers can be changed, allowing the system to be used for making a variety of crucible sizes and shapes. Our roller forming process produces a dense crucible with good thermal conductivity, excellent thermal shock resistance, high mechanical strength and refractoriness, and very high resistance to damage caused by fluxes. And because the roller forming cycle is fully programmed, every crucible produced has identical properties and offers uniform performance. Isostatic pressing, isopressing for short, is a specialized manufacturing process that uses a liquid or gas medium to apply uniform and simultaneous pressure from all directions on a material being compacted. At Morgan MMS, we use this process to make syncarb clay bonded graphite crucibles and ultramelt carbon bonded silicon carbide crucibles. Isopressing produces crucibles with the highest possible density, reduced porosity, and a homogeneous material composition from bottom to rim. We also use this process to manufacture silicon carbide degassing rotors and filling funnels. The key operating principle is to put the crucible material to be compacted between an unyielding steel surface and a flexible surface that will expand or contract in response to the isostatic pressure generated by the press. Accurate positioning of the core is essential before the mold is closed and moved via automated conveyor to the filling station. There, an overhead material dispensing system is used to fill the mold with the clay graphite or silicon carbide material specified for the crucible being made. When the mold reaches the isopress, it is loaded onto a lift that lowers the mold into the pressing chamber, which is filled with water. After the chamber is sealed, the isopressing cycle is initiated. First, pressure is increased via oil pumps until the maximum pressure is reached. Then, after a brief holding period at this pressure, decompression begins in fixed steps until all pressure is removed. At the end of the cycle, the lift returns the mold to the conveyor level, where it is moved to the demolding area, where the crucible is removed from the mold. Coking is a key step in the manufacture of silicon carbide crucibles and foundry products. Coking combines thermal and chemical processes that serve to convert the relatively impure organic coal tar material used as a binder in green crucibles to the highly pure elemental carbon binder required in the finished products. Here's how it works. First, large empty crucibles culled from previous finished batches are assembled on small flatbed rail cars, which are moved into position for loading. Next, green silicon carbide crucibles, which have completed the drying process, are positioned on the loading deck in size order, largest to smallest. A lifting device is then used to move each green crucible into a holding crucible on the rail car. Starting with the largest green crucible, they are nested like a Russian matryoshka doll, one inside the other, until the smallest has been placed in the center. A mix of bauxite grains is then used to fill all the spaces beneath, between, and on top of the green silicon carbide crucibles. An intricate system of rails and shuttle cars is used to move the crucibles to the entrance port of the gas-fired tunnel kiln. The kiln is 48 meters or more than 157 feet long. It operates 24/7. The green crucibles, with their bauxite covering, spend the next 2 to 3.5 days moving through the kiln, reaching sustained temperatures often exceeding 1,000 degrees Celsius or 1,800 degrees Fahrenheit. After the crucibles are removed from the kiln, the bauxite is cleared away and the crucibles are taken to the impregnation chamber for the next step in manufacturing high-quality silicon carbide crucibles and foundry products. While a crucible's exterior glaze protects the crucible's inner and outer surfaces from oxidation, a thermal and chemical process called impregnation protects the internal structure of the crucible material itself. This increases the crucible's service life. The impregnation process begins with loading the crucibles into a special steel tank that is both a vacuum chamber and a pressure vessel. Next, the chamber is filled with the impregnation solution and heated. Finally, the chamber is pressurized. During this process, the impregnation solution infiltrates into and fills the pores of the crucibles, where it solidifies and becomes a permanent part of the crucible structure during the subsequent final firing. After a 1-hour cycle time, the chamber is drained, unsealed, and the crucibles are removed and coated with a glaze. Spouts are often incorporated in crucible designs to facilitate pouring. In some crucible products, the spout is molded or formed as an integral part of the crucible during rib forming, roller forming, or isopressing. In other cases, the pouring spout is cast separately from the crucible and attached to it during crucible manufacturing or while the crucible is being installed in the customer's furnace. The installation craftsman uses a steel file to shape the specified preformed spout's contact surfaces to match the curve of the crucible. Here, he carefully marks the spout's position on the crucible. Next, he transfers the spout's contact surface dimensions to the crucible's surface using an etching tool. Following these lines, he quickly cuts a roughly shaped notch in the rim of the crucible. Now, the highly exacting work of finally shaping both the crucible and the notch begins. It takes the accuracy of a skilled craftsman's eye and well-practiced hands to almost seamlessly match spout and crucible. The spout must fit tightly, provide the proper pouring pitch, and be absolutely level with the top of the crucible. Next, the spout is trimmed to the proper length and the final fitting adjustments are made. The carbon binders and the graphite in crucibles would burn when exposed to heat and oxygen, so we apply a variety of durable glass-like glazes to seal the crucible from oxygen in the air. Like the crucible materials themselves, glazes are engineered to provide specific performance characteristics such as resistance to chemical attack, to thermal shock, and to physical damage. After the glaze is applied, each crucible is moved to the firing area where large movable kilns are loaded with the crucibles and other foundry products. Loading a kiln is a carefully planned process designed to position each piece to allow complete circulation of the hot gases on all sides. The temperatures which have to be reached depend on the type of crucible and glaze. It is between 1000 and 1350 degrees Celsius. That's 1800 to 2450 degrees Fahrenheit. After being fired at high temperature in our large kilns, these glazes help prevent damage to the carbon in crucibles and greatly extend their service life. After firing has been completed, each crucible is inspected by an experienced quality control professional to ensure that only crucibles meeting our strict standards move to the next steps: painting to provide quick and easy identification, and shipping. From our large inventory of crucibles and foundry products, we supply Morgan Molten Metal Systems customers around the world with durable premium quality crucibles designed to exceed their demanding performance requirements.